Okay, in this video, we're going to take a single logarithm and we're going to write them as a string of simpler logarithms connected by addition and subtraction signs, or as sums and differences. Again, we're going to be using the product rule, the quotient rule, and the power rule as we go along to rewrite these. So the first thing I'm going to do for 26, I'm going to unpack the numerator and the denominator. And first, I'm going to write that as the difference of two logarithms. So this is equal to log base b of the numerator, x squared times y, minus log base b of b to the third. And so, of the denominator. And so now I'm going to see what I can do to simplify this further. When I look here, I see x squared times y. That's two things being multiplied, so I can use the product rule to rewrite that. So I'm going to do that. This is log base b of x squared plus log base b of y minus log base b of b to the third. Then I'm going to see what else I can do to simplify this. I can use the power rule to take this exponent 2 and to move it to the front. I'm going to do that. I could do the same thing with this 3, but I could also use the inverse property, which we talked about in class, and on your sheet it says log base a of a to the x is equal to x. So that means that log base b of b to the 3 is just equal to 3. That is a logarithm and an exponent. Those are inverses undoing each other. So this is just going to be a minus 3. If I take this 2 and move it in front, it's 2 log base b of x plus log base b of y minus 3. That is the simplified form of 26. Let's look at 28. We're going to do the same thing. The first thing we should do is unpack the numerator and the denominator. Now, I did not see a base written there, and that means that the base is 10. When they don't write log base something, it's missing, we understand that to be a 10. And I said it is fine with me if you guys write the 10 in, no problem. So if you wanted to say, oh, I know that that's a 10, and you write the 10 right there, that is fine with me. This is equal to, I'm going to unpack the fraction, the numerator minus the denominator using the quotient rule. So this is log base 10 of 5a, the numerator, minus log base 10 of 4b squared, the denominator. Then when I look here, 5 and a, these are being multiplied. I can use the product rule. So this part's equal to log base 10 of 5 plus log base 10 of a. Minus, and then whatever I choose to do after the minus sign, the minus gets applied. So I'm going to introduce a parentheses right here, and I'm going to separate these using the product rule because these are being multiplied. This is going to be log base 10 of 4 plus log base 10 of b to the second. And so since I slipped that little 10 in there, I'm going to write it everywhere. You can write the 10 if you want to. All right, so the only thing left to do is I need to distribute this negative to both of these terms, and I'm going to take the 2 and I'm going to put it in front of this logarithm. So I'm going to move the power to the front. So this is going to be log base 10 of 5 plus log base 10 of a minus log base 10 of 4 plus 2 times log base 10 of b. And that is what that expression can turn into. All right, lastly, down here, I made this one up. This is not on your green sheet. I just wanted you to have another one that you could look at. Natural log means log base e. And so I'm going to do the same thing. I'm going to unpack the numerator from the denominator. And sometimes, lots of times on these problems, there'll be an extra instruction. It says express as sums and differences of logarithms. And then it will say write powers as factors, or it will say express powers as factors. What that sentence means is, see this power of 2? I rewrote it in the front as a factor. It's 2 times the log base 10 of b. That's what they want you to do when they say that. And so most likely I will ask you guys to do that as well. All right, this is the natural log of the cube root of y over x squared times z. So first I'll unpack the numerator and denominator using the quotient rule. This is the natural log of the cube root of y minus the natural log of x squared times z. All right, now I'm going to do two things. I'm going to use the product rule here and separate this into an addition of two logarithms. And I'm going to rewrite this cube root of y as y to the third. So here is the conversion. The nth root of a to the m is a to the m over n. So in other words, x, the square root of x is equal to x to the 1/2. The cube root of x is equal to x to the 1/3. Or something like the fifth root of x squared would be x to the 2/5. That's how you can convert between radical and fraction powers. So right here, this is equal to the natural log of y to the 1/3 minus, and whatever I do after the minus sign, the negative gets applied. So this is the natural log of x squared plus the natural log of z. This is equal to, I'm going to kick the power in front. Write powers as factors. I'm going to move the 1/3 to the front. 1/3 times the natural log of y minus 2. I'm going to move the 2 to the front here. Times the natural log of x. This negative also gets distributed here minus the natural log of z. And that's the final answer for that one.